We are going to be looking at more inverses today, and so we are going to again find spots on the unit circle where things happen. The problem is today there's going to be spots where we don't have coordinates for. Okay, so in this first example, again, you're going to start inside out, and so I'm asking you to figure out this, and this is basically asking you to figure out tangent at some spot on the unit circle, there's your big question mark, has a value of 1/2. Okay, so the problem today will be this. When you go to your unit circle, you know that tangent is y over x. And if you try to do y over x at any spot, you're never going to be able to get it to be 1/2. Because 0 over 1 will be 0. 1/2 over root 3 over 2 is going to end up being root 3 over 3 when you simplify it. Root 2 over 2 over root 2 over 2 will end up being 1 when you simplify it. Root 3 over 2 over 1/2 will end up being root 3. And then 1 over 0, of course, is undefined. And the same pattern is going to continue all the way across. So there is no spot on your unit circle where tangent is 1/2. Okay? So when I just look at the inside piece, I am not going to be able to figure out where that spot is. But in the end, my goal anyways is to be able to figure out sine at whatever spot this happened at. Okay, that's my goal, is to figure out sine at whatever angle this is. Okay, now I'm not going to know the angle, so I'm not going to know that it's 42 degrees or whatever, but I do know what the tangent value at that spot is, and if I know the tangent value at that spot, then I can figure out what the sine value at that spot is. Okay, so here's what you kind of need to think about. Okay, tangent in this case has a positive value of 1/2. Okay, if we look at our restricted intervals, tangent is restricted between negative pi over 2 and positive pi over 2. So tangent is restricted to over here. In this quadrant, your tangent or your y over your x will be positive, and in this quadrant, your tangent or your y over your x or your opposite over your adjacent will be negative. So we know for sure that we are working in quadrant 1 because of the restricted intervals and tangent down here being negative. Okay? So I'm in quadrant 1. If I draw kind of my handy dandy little triangle, it's going to look something like this. I know I'm in quadrant 1 and my triangle will look like that. Obviously this is my theta. Your tangent is your opposite or your y over your adjacent, which is your x. And then you can do a squared plus b squared equals c squared. So I'll do 1 squared plus 2 squared equals my radius squared. 4 plus 1 is 5, so 5 is your r squared, so r will be the square root of 5. And remember that your radius is always positive, so you don't need to worry about positives or negatives there. Okay, so this side over here is your y, or your opposite, and this side right here is your adjacent, or your x, and this side right here is your radius, or your hypotenuse, sorry. Okay? So sine now, we know, is our opposite over hypotenuse, or our y value over our r value. So our sine will be 1 over the square root of 5, which of course will simplify to root 5 over 5. Okay, and that is my answer. So we'll do a couple more here. Okay, this is asking me to figure out, in the middle, cosine at some spot on my unit circle, that's my question, has a value of negative 1/3. Okay. I don't know what that spot is, and if you go to your unit circle, remember that cosine is your x value, and there will be no spot anywhere on this whole entire unit circle where your cosine values will be 1/3 that you have coordinates for. Okay, so you're going to have to kind of do some other things. In the end, though, my goal is to be able to figure out tangent at whatever spot this happened at, okay? And again, I don't know what angle it happens at, but I can figure out the tangent value because I can use the fact that cosine is negative 1/3 to figure out tangent, okay? So now, first of all, I need to worry about what quadrant I'm in. I am going to use cosine's restricted interval because that's where the arc is in front of, or the cosine negative 1. Remember that arc is the same as inverse cosine, or cosine negative 1. Okay. Cosine is restricted to, I want to go the other way here. Cosine is restricted to, if you look between 0 and pi, so cosine is restricted to this area over here. In quadrant 1, cosine is positive, and in quadrant 2, cosine is negative. So I know for sure that I'm working in quadrant 2. Okay? So again, I don't know what theta is. I just know that it's an angle in quadrant 2, and I'm going to use the information I have to figure out tangent at that spot. Okay? So what I'm going to do is I'm going to draw my triangle, which I know is in quadrant 2. Cosine is my adjacent over my hypotenuse. So my adjacent will be -1, which is also my x value. My hypotenuse is 3. The hypotenuse can never be negative, so you know for sure that the negative goes in with the 1. Also, you're moving to the left, so you know the 1 has to be negative. My hypotenuse, or my r, is 3. Okay, and then again, you're going to do a squared plus b squared equals c squared. -1 squared plus y squared equals r squared. Okay, so 1 plus y squared equals 9. Y squared then, of course, will be 8. Y will be positive or negative square root of 8. And of course, that can be broken down into 2 root 2. And then you need to think about whether it's positive or negative. You're in quadrant 2 where you're moving, your y values are going up and not down. So your y value should be positive 2 root 2 right here. Okay? And again, this is your y value or your opposite. Okay? So my goal in this problem, once again, is to figure out tangent at whatever angle this is. And I don't know what angle it is. I know it's somewhere between 90 and 180 degrees. I don't know what angle it is, but I have enough information to find tangent at that spot. And tangent will be opposite over adjacent, or y over x. And so it will be 2 root 2 over -1, or -2 root 2. Okay? All right. This now, you guys, are ones that you are actually going to enter into your calculator. There is not a spot on your unit circle. Actually, there is a spot on your unit circle where secant is 2. Sorry, I'm taking this back. I'm going to step ahead here. This is asking you to figure out secant at some spot on your unit circle is 2. That's what inverse means. That's your big question, is what's that spot? And just remember my little trick. Secant is the reciprocal to cosine, okay? And so if figuring out where secant is 2 is the same thing as figuring out where cosine, or my x values, are positive 1/2, okay? So my x values, or my cosine values, are 1/2 right here at 60 degrees, and they are also 1/2 right here at 300 degrees, okay? Cosine, though, is restricted to answers that are between 0 and pi. Whenever you see that -1 symbol or the word arc, you need to remember that you have to use restricted intervals. So cosine is restricted to between 0 and pi, and so therefore, I know that this answer up here will count, and this one will get the x. So I know that my answer will be pi over 3. All right. Figuring out where cotangent is root 3. Again, you're going to need to use restricted intervals. It's maybe not going to help you very much with cotangent, but I do want you to remember the little trick. Cotangent is the reciprocal to tangent. So this is the same thing as asking you to figure out tangent at some spot is 1 over root 3, which of course you can simplify to root 3 over 3. Doesn't really help you much with tangent and cotangent, but it is a trick that I want you to remember. Tangent has to be root 3 over 3, and so you're going to kind of go around and simplify. So over here, of course, 0 over 1 is not going to give you that. If you have 1/2 over root 3 over 2, and you flip it, then those are going to cancel, and you're going to get 1 over root 3, which of course simplifies to root 3 over 3. Okay, and now let's think about, is that what we want? Yes, it is. Okay, so that happened right there at pi over 6, or 30 degrees. Okay, now this, if we go to our unit circle, figuring out where cosecant is -4 is the same as asking you to figure out where sine is -1/4. Okay? And when I go to my unit circle, I don't have a spot where sine is -1/4. Remember that sine is your y value, or your up-down value, and there is no spot on your whole entire unit circle where your up-down value is 1/4. So on this particular one now, you have no choice except for to be able to go to your calculator and punch this in. And remember, I think I kind of taught you this the other day, but I'm going to keep reminding you of this. When you punch this into your calculator, and you have the cosecant, you have to use the little trick that I just taught you and change cosecant to its reciprocal in order to be able to enter it in. Otherwise, it's going to give you an error. Okay, so hang on, my calculator is booting up for us here. All right, so the inverse of cosine, being 4, is the same as figuring out the inverse of sine at 1/4. And now I'm thinking, is it +4 or negative? It is negative, okay? At -1/4. So I need to change this. Second sine of -1/4. And it's, for my calculator, it spits out -0.2526, which is maybe different than your calculator screens out. Your calculator screen prints out. That's because my calculator right now must be in radian mode. So if you want your answers to spit out in degree mode, then you have to press the mode key and change it to degree. Hit enter, and now let's try it again. Okay, so inverse sine of -1/4 gives me -14.47 degrees. Now, you need to know this. I never want your answers in negative angles, okay? You have to give me your answers in positive angles. So for this particular one, I got -14.47 degrees. But you need to think about where that is on your unit circle. So -14.47 means you rotated 14.47 down this way. Okay. But I want that angle as a positive angle. So I want this distance right here. So to figure that out, you're going to go 360 minus 14.47, which of course will give you 345.53 degrees. Okay? And that will do it for you. So this is your homework for tonight. We will see you next time.